From the previous video, we have seen how Apache Kafka at least once delivery works. In that video, we have demonstrated how durable at least once is. Even though we crash or stop the leader of the partition we are producing to, our messages were intact, though there is one problem to that. Because of producer retry, message duplication is possible. And what if in your business case, duplicate messages are not acceptable? In this video, we will test how Kafka handles exactly once delivery. With exactly once message delivery, messages will not be lost and will not be duplicated. Exactly once is transactional, which means all or nothing. But we will see that in action. Let us first understand what it means. We can think of an analogy to compare with exactly once message delivery. We will take delivery company for an example. Let's say you bought an expensive smartphone online. For expensive items delivery, the delivery company will usually call or send you a message of the date and expected time of delivery. When the delivery person comes to your house and deliver the item, they will also ask for your signature. This confirms you have received the item. In Apache Kafka exactly once delivery semantics, when a producer connects to a broker, the broker assigns an ID or PID to the producer. Also, behind the scene, the producer generates monotonic sequence number for every partition that it is consuming. The producer sends messages in transaction with the generated sequence number. Also, the producer tracks and increments the sequence number for every successful message delivery. At the other end, the broker will track each received message with its producer ID and the sequence number that was sent with the message. The broker will record the sequence number of the last message it successfully append to the partition. If a message is duplicated, the broker will silently drop the message. If a producer is sending messages to multiple partitions, each partition will have its own independent sequence number. To have a complete exactly once semantics, the consumer also consumes record in transaction. After it polls for message, it processes or transforms the message in the same transaction, and it will send message to an output topic together with the commit offset of the message it processed. A meaningful use case for exactly once is for topic that hold data that needs transformation. For example, let's say you have Euro to USD business case where users transfer money from Euro account to dollar account. Your Kafka producers send the transaction event to Euro topic in transaction. And in between, you have a Kafka consumer that consumes the Euro topic messages, converts the money to USD, and forward the message to USD topic. You could have other consumers that consume the USD topic and persist the data to database. This is what exactly once delivery means. The producer sending messages in transaction with acknowledgement of all, retry set to some value, let's say maximum int, and a transactional ID to some value with enable idempotence to true, and with consumer isolation level to read commit, and committing the process message in transaction means all or nothing is guaranteed. We will see this practically in a moment. I want to thank you all for watching this video. Don't forget to like, subscribe, and share. Let's continue. We will start by checking and launching our Kafka cluster using Docker Compose. We are going to use the same Docker Compose file we did in the previous videos, at most once and at least once delivery videos. So as you can see, it's the same Docker Compose file. I have 3 controllers and I have 3 brokers. As usual, our setup is in Kraft mode. So we will be having 6 nodes. So let's go ahead and start our Docker Compose to create our cluster. And also I will just start it in a normal mode because I want us to see some of the logs there. So let's start it. As you can see now, our cluster is ready. So let's go ahead and continue. With Exactly-Once Semantics, we are going to use two topics. We'll call them payment and payment analytics. We will clean up these topics and create new ones with 3 partitions, 3 replicas, and 2 minimum in sync replicas to have a clean environment for our test. So let's first check our Docker PS and see our cluster. You see, we have 3 brokers and 3 controllers. So one of the things we are going to do first is to check whether how many topics we have. For example, by running this command, I can see I have payment analytics already, I have payments, and then I have transaction. First, let us delete everything. I mean, not all the topics, but at least the topics that we are going to work with so that we can have a clean environment. And then also for the analytics topic. And now we have deleted everything. If we go back and list, we can see that they are no more there. So the next thing we are going to do is to create each topic again. So let's say we start with the payment topic and we create it. As you can see, I said with 3 replicas, 3 partition, and 2 minimum in sync replicas. So the payment is created. Let us also create our payment analytics topic. So let's go ahead and do that. It is also created. We want to target the leader of the partitions we are sending message to crash or stop while we are sending our message. Because we are dealing with 2 topics, we can target the leader of any of those topics. So let us check the leaders of partition 0 in payment. For example, we can see node 4 is the leader of partition 0 in payment topic, and we can also check for the payment analytics. Let's see the same thing. Node 4 is also the leader of partition 0 in payment analytics. Okay, let's start with our Java app now. As you can see, as usual, I have this controller that just loop and send 10 messages. But also, if we go to the producer config, we can see that, yeah, some things are as usual with the order delivery guarantees, like the acknowledgement and then the retries. But you can see, like, we have additional idempotence set to true, and then we also have additional transactional ID. We enable idempotence to true, which ensures even if the producer retry, Kafka will make sure only one message is appended. Another thing the producer does, it generates a monotonic sequence number behind the scene and send it with the message. It increments the number whenever a message is delivered successfully. We have talked about this before. We also have transactional ID set with some values. You can use any name or value you want for that, but the name or value has to be unique across your producers. Kafka broker uses this together with the monotonic sequence number sent with message to track last appended message. If we also go to the producer, we can see nothing much here except that we are also sending to partition 0, and this time around we are sending to payment topic. If we continue with the consumer config, here you can see I have added isolation level to read commit. In consumer, the additional config is the only isolation level which we set to read commit. This ensures that we only read the messages that are committed in the transaction, because it is not necessarily true that all messages sent through transaction are committed. In transactional producer, the producer send message, then get acknowledgement, then it send another request for the message to be committed, and that is why we set the isolation level to read committed only. And if we also go to our consumer, we can see I have 2 consumers here. I have a consumer for the payment topic and I have another consumer for the payment analytics. Another very important thing, I don't know if you have noticed it, if we check the consumer config, even though I have set the acknowledgement mode to manual, when we come to consumer, you can see that even even though I have set acknowledgement mode to manual in the configuration, because the consumer is processing the message in transaction, the operation here, as you can see below here, the operation send offset to transaction actually tells Kafka to commit the offset of the processed message as part of the transaction. So when transaction is successfully committed, Kafka will also persist the offset, and because of that, we don't have to call the acknowledgement manually. Unlike if we go down here, you can see I'm calling the acknowledgement manually, but here, because it is in transaction, this transaction is telling Kafka to commit the transaction and also commit the offset of this message that the listener or the consumer has consumed. So we will now launch our Java app so that it will stay ready and wait for us. So let us come here, or we can even start it from here. Okay, let's just click run and start the application. Okay, now that our postman is ready to send message, and also I have written the command already to stop the broker 1, which is node 4 as we see, and node 4 is the leader of partition 0 that we are sending messages to. So immediately I click on send. While our controller is generating the 10 messages and sending, I will then come and stop the broker. So let us go ahead and do that. Now I click send, and then I'm back here. I'm stopping the broker. I am now stopping the broker. So the broker also has stopped. Okay, now that the broker has stopped, we can go and see what is going on with our cluster. And yeah, we have seen like node 4, it has stopped completely. And also we know Kafka will automatically re-elect a new leader for the affected partitions. We can also go to our Java app and see what has happened there. For example, we can see the consumers and everything. I mean, you can check the logs after you do the test yourself. We are not going to spend much time analyzing the logs, but one thing we have seen, like definitely the Kafka cluster have re-elected a new leader for the affected partitions. And you know, we are dealing with two partitions. That is partition 0 from the payment topic and partition 0 from payment analytics topic. Let us go to our terminal and also see some of the changes, or who now is the leader of partition 0, for example. For the payment, let us describe it again. We can see node 5 is now the new leader, and we can also go ahead and see who is the new leader of partition 0 in payment analytics, and we can see again node 5 is the leader of partition 0 for payment analytics. Okay, that's great. Now let us verify if our messages have all made it to the topics and whether we have duplicate or missing messages, which we are not expecting. Let's start first with the payments and see how many messages are in the payment topic. And this time around, we are just going to count the messages, how many messages are there in payment topic. And we can see that our producer sent all the 10 messages, no lost, even though when you are sending the message and the broker crash, then the producer will keep on trying. Okay, let us also go and count for the payment analytics and see how many messages do we have there. Also for the payment analytics, we have complete total 10 messages. So we sent 10 messages and we have 10 messages in both sides. Okay, what did we learn? In this video, we explored how to achieve exactly-once delivery and processing in Apache Kafka. We started by understanding what exactly-once semantics mean in Kafka: no duplicate, no message loss, and no double processing, even in failure scenario. We configured the producer for idempotence and transactions, ensuring that messages are written safely to Kafka topics. On the consumer side, we use Kafka transactions to process messages and commit offset automatically, giving us true end-to-end Exactly-Once Semantics guarantees. Finally, we tested how Kafka handles failures and transactional commit and proved that when done correctly, Exactly-Once Semantics is both reliable and production ready. If you are building financial systems, event-driven microservices, or any workflow where correctness matters, then Exactly-Once is your go-to. Don't forget to like this video, drop your questions in the comment, and don't forget to subscribe for more deep dive into Kafka and some technical hands-on in back-end development. See you next time. Enjoy yourself. Bye bye.